Hello everyone. Now we will learn about the knowledge of boiler startup and shutdown. The key points in this section are as follows. 1. Boiler startup and shutdown methods. 2. Basic procedures for joint boiler startup. 3. Basic procedures for joint boiler shutdown. 4. Cold startup of 1 through boilers. 5. Shutdown of 1 through boilers. Boiler startup refers to the process by which the boiler transitions from a non-operational state to an operational state, while boiler shutdown refers to the process by which the boiler transitions from an operational state to a non-operational state. The startup and shutdown processes of the boiler unit have a crucial impact on the safety and economic efficiency of the boiler. First, boiler startup and shutdown methods. The startup and shutdown methods for power plant boilers include individual boiler startup and shutdown, and boiler turbine generator, combined startup and shutdown. For boilers with a main steam head system, individual startup and shutdown methods can be used for unit system boilers. Combined startup and shutdown methods are used. In China, reheat units with a capacity of 125 MW and above are all unit systems. Units using sliding parameter combined startup and shutdown methods. 1. Sliding parameter startup and shutdown methods for boilers. Sliding parameter combined startup refers to the process while starting from a certain stage during the startup. The isolation valves and control valves between the boiler and the turbine are fully opened. As the boiler pressure and temperature rise, the turbine is sped up, accelerated, synchronized to the grid, and loaded during the startup process. The relationship between the boiler and the turbine is close and mutually restrictive. The startup phases and conditions must be mutually coordinated and consistent. Sliding parameter combined startup is further divided into vacuum method and pressure method. Modern large units mostly use pressure method. Sliding parameter combined startup. Its characteristic is that the turbine generator is spun up only after the steam at the boiler outlet reaches a certain pressure and temperature, then gradually transitioning into sliding pressure operation. Before the turbine is spun up, the main steam valve is closed, and the steam is discharged through the turbine bypass into the condenser. During the sliding parameter combined shutdown process, the valves between the boiler and the turbine are also fully opened. As the boiler reduces fuel pressure and temperature, the turbine also reduces pressure, temperature, and load. 2. Boiler shutdown. Boiler shutdown is generally divided into normal shutdown and emergency shutdown two situations. Planned boiler maintenance shutdown and shutdowns according to dispatch orders fall under normal shutdown. Due to accident reasons, when it is necessary to stop boiler operation, it is considered emergency shutdown. Normal shutdown is further divided into maintenance shutdown and hot standby shutdown. The former anticipates a longer shutdown period, usually for major or minor repairs, or when scheduled for cold standby requiring the boiler to cool down to a cold state. The latter has a shorter shutdown period, usually scheduled for load dispatch or urgent repairs, requiring the boiler shutdown to maintain a high temperature level in the unit's metal, so that it can be restarted in a hot or extremely hot state, thereby shortening the startup time according to the characteristic of parameter changes during the boiler shutdown process. It is also divided into sliding parameter shutdown and fixed parameter shutdown. During fixed parameter shutdown, the boiler parameters remain unchanged or basically unchanged. It is usually used for emergency shutdown and hot standby shutdown. Second, basic procedures for drama boiler startup. Drama boiler startup include natural circulation drama boilers and controlled circulation drama boilers. Their startup and shutdown processes are similar and are collectively referred to as startup and shutdown of drama boilers. The basic procedures for the cold startup of natural circulation drama boilers using the sliding parameter pressure method are as follows. First, preparation work. During the preparation phase, a comprehensive inspection of all systems and equipment of the boiler should be conducted and put them in a state ready for startup to ensure the safety of equipment. During the startup process, all detection instruments, interlocking protection devices, primary MFT functionality, critical auxiliary interlocking trip conditions, and control systems, mainly including FSSS and CCS systems, have been inspected, tested, and fully commissioned. Other preparation work includes 1. Power supply to the plant. 2. Unit equipment and its systems are in a state ready for startup with remote control, program control, interlocking, and other thermal protection activated. 3. Preparation and storage of chemical demineralized water system startup. 4. Water flushing of generators, condensers, water tanks, etc., until the water quality is qualified. Then, filling with demineralized water, starting the condensate pump, starting the circulating water pump, and then establishing a circulating water siphon. 5. Preparations for the startup of the turbine and generator. 2. Boiler water filling. 3. Boiler ignition. 4. Boiler temperature and pressure rise. 5. Automatic control devices commissioning. Third, basic procedures for German boiler shutdown. The combined shutdown of unit systems using sliding parameters. Depending on the parameters, when the unit is shut down, can be further divided into lower parameter shutdown and medium parameter shutdown. Shutdown with main steam pressure sliding down to 1.5 to 2 megapascals and steam temperature at 250 degrees Celsius. The corresponding turbine load is called lower parameter shutdown, used for maintenance shutdown. Shutdown with main steam pressure reducing to 4.9 megapascals at the corresponding turbine load is called medium parameter shutdown, used for hot standby shutdown. The basic procedures for sliding parameter shutdown can be divided into 5 stages. First, shutdown preparation. For low parameter shutdown, before the shutdown, 6 clean tests must be completed, which are cleaning the cool bunker, cleaning the powerizing cool bunker, cleaning the heating surfaces, cleaning inside the boiler, cleaning the furnace bottle, and cleaning the ash hopper. For medium parameter shutdown, before the shutdown, it is not necessarily required to comprehensively perform the 6 cleaning tasks. Generally, only the heating surfaces inside the boiler and the furnace bottom need to be cleaned. The turbine generator should be prepared for shutdown. Second, pressure reduction preparation. Third, pressure reduction and load reduction. Fourth, turbine shutdown, boiler flame out. Fifth, boiler pressure reduction and cooling. Fourth, cold startup of once-through boiler. Startup characteristics of once-through boiler. First, before startup, the steam water system must be cyclically cleaned. Second, a certain startup flow and startup pressure need to be established. Third, the heating rate of the once-through boiler must be limited. Fourth, during the startup process, there is a phenomenon of working fluid expansion. Startup bypass system for once-through boiler. The startup bypass system for once-through boilers is specifically designed to address the startup characteristics of once-through boilers. Its main functions include establishing startup flow, steam water separation, and controlling work fluid expansion. Its key equipment is the startup separator. The role of the startup separator is to separate steam and water during the startup process to maintain the water wall startup flow while also providing steam to the super system and recovering working fluid and heat. The startup bypass system for once-through boilers is divided into external and internal types. Third, cold startup procedure for once-through boiler. 1. Preparation before startup. Before startup, a comprehensive expansion of the boiler, turbine, and generator systems should be conducted, and the boiler hydrostatic test, furnace tightness test, valve and jumper liberation, boiler interlocking test, and rotating machinery trial operation should be completed. Some auxiliary systems should be put into operation or prepared for startup. The coal bunker should have sufficient coal, and the powerizing system should be prepared for operation. The rotary air preheater should be put into operation. 2. Cold circulation cleaning. 3. Boiler ignition. 4. Hot cleaning. 5. Temperature and pressure rise. 6. Turbine rotation, warm-up and initial load. 7. Separator transition from wet to dry state. 5th. Shutdown of once-through boiler. The normal shutdown of a once-through boiler also involves several stages, including preparation before shutdown, load reduction, flaming out, and pressure reduction and cooling, compared to German boilers. The main difference is when the boiler's combustion rate drops to around 30% due to the need to maintain the water wall flow at the startup flow and no further reduction possible. Therefore, during the process of further reduction fuel and lowering the load, the working fluid at the outlet of the leading superheater changes from slightly superheated steam to a steam-water mixture to a white water ingress into the front screen superheater. The boiler must engage the startup separator to ensure that the working fluid entering the front screen superheater remains dry and saturated steam, preventing damage to the front screen superheater tubers. Classmates, in this section, we have learned about the startup and shutdown methods of boilers, the basic startup procedures for John boilers, the basic shutdown procedures for John boilers, the cold startup of one-flue boilers, and the shutdown of one-flue boilers. These pieces of knowledge are all related to the safe operation of boilers. Today, regarding the content of boiler startup and shutdown, we will introduce it here. Thank you all.